The question says that two particles each of mass m and speed v travels in opposite directions along parallel lines separated by distance d. Show that the angular momentum vector of two particle system is same whatever be the point about which the angular momentum is taken. So this picture represents the situation in this question. Like there are two particles, one particle is at L and another particle is at N. Now they are moving parallelly to each other. Now these two lines represents the parallel movement of these two particles. One particle is moving up and the other particle is moving down. So we have to prove that irrespective of where you take the angular momentum from, it is going to be constant. So we have taken 3 points, L, M and N. M is exactly in the midpoint of the line connecting these two vectors at the moment. So we know that angular momentum is defined as the cross product of R and the linear momentum. Linear momentum of the particle at position L would be in the same direction as it is moving, that is the direction of its velocity. And so let us now calculate the angular momentum about the point L. So angular momentum about point L would, for this particle at point L, would be 0 because the position vector would result out to be 0. Now the position vector for the particle at point N would be directed in this direction. Now the magnitude of this position vector is going to be the distance, magnitude of this distance, that is d, and its direction would be in this direction towards the particle at point N. So according to this formula, R cross P, there is a cross product. So we know that R cross P is R P sine theta, the magnitude of R vector, magnitude of P vector multiplied with sine theta, and theta is the angle between these two vectors. Now here position vector and velocity vector is making an angle of 90 degree. So we can say that sine theta is going to be 1 and magnitude of R is the d and magnitude of P is m times v. So angular momentum about point L is going to be mvd. Now its direction is going to be into the plane according to the right hand rule. So we can say it is going to be into the plane. Now let us find out the angular momentum about the point M. So position vectors for the particle at point L would be this, and for the particle N would be this, both having the magnitude of d by 2 and d by 2. Now we see that both of this angular momentum of this particle L and N would be directed inside the plane as taken from the right hand rule, and the magnitude is going to be mv times d by 2 because sine theta again would be 1 because the angle between the velocity and this position vector is again going to be 90 degree. So simply we can add this as these two momentum have same direction. So it is going to be mvd, and this is exactly same as we calculated in the previous case. Now angular momentum about the point N, that is the another particle, similarly as was in the case with particle at point L, we see that the magnitude is same as mvd. So we come to the conclusion that irrespective of whether the location from which the angular momentum is calculated, it is going to be constant. Thank you.